Hello, welcome to another episode of Xa Talk Show. Today we are going to do Wolfram language coding. So this is gonna be relaxed session. And it's probably going to be boring for you. So if you want a focused tutorial on Wolfram language, you probably better just go to my Wolfram website, okay, Wolfram language tutorial, and I've done a lot of introductions to Wolfram language. So you go there and search for Xa Wolfram language tutorial. You go there and watch a collection of my best Wolfram language videos there. That gives you an intro. And today, I'm just going to code Wolfram language. I'm going to code Wolfram language, and it's going to be about walking a directory. So you want to get a list of files in all directories and subdirectories, and you want to tally the word count. And you want to also work on Wolfram association data structure, which is like Python's dictionary, Perl or Ruby's hash table, or JavaScript and Java's map data structure. So in Wolfram language, it's called association, this data structure. And in Lisp languages, it's called association list. So it's basically a list of key value pairs. So I'm just going to leisurely, today I'm going to work on them, live coding, okay? So there it is, Wolfram language, and here is Xa Discord. You can join this Xa Discord, and we have fun chat. Okay, so we are going to code Wolfram language. Today's topic, just live coding. Hello guys, hello Johan, Dewao, and Immortality, and JR. Okay, so if you have comments and questions, post it, okay? I'd love to see it. And don't forget to donate, cha-ching! That's the most critical part, okay? That's why, if you like my stuff, just do it. $5, $20, just do it. Just like Nike, Okay, so Wolfram language. So let's do. So last time, a week ago, 2 weeks ago, we did this word count. So let's start. Okay, so here is Wolfram language. We already started. Let's magnify. Let's see. Let's magnify. Let's see. 150. Okay, and what we want to do now, I want to read the file and tally the word count, and also the count of every two words, the frequency. So okay, so let's see. Why don't we just copy the code here? We had the code here. Okay, so anyway, so here is today's talk show, and let's start coding. Okay, Wolfram language, paste the code here, pop it out to a Xa Wolfram language mod. This allows me to work on Wolfram language in Emacs. Okay, and here is the file. Last time we used, this is Arabian Nights. It's fantastic. I recommend it. The Book of 1001 Nights, the real thing, not the Disney version. You will see lots of amazing, tales, the Arabian Nights, not the Disney thing. So we are going to use this. Okay, so here is the file. We want to count the words in that file. So input string. So let's see. Yeah. Okay. So let's do it. Let me just show you one by one. Actually, so delete that. Wait. Delete that. No, you need to press the delete key. So first of all, clear X. Yeah. Okay, because I had an X there. So here's the file path. So we want let's just copy it then. Okay, so paste that. Delete, paste that. copy that back here, select all, delete, paste. Okay, so input read string, so that we'll read the whole file's content into the X input. And now we want to do find replace. Okay, so find replace and paste it. So this will, here's a regular, find string replace is a function you want to use. X input is a HTML source code. For example, let's look at the source code. Control U. So here is the source code. Let me magnify the browser's font. Okay, so we can see better. Okay, so here's the source code. You can see lots of HTML. So we want to remove HTML tags. So that's why you call string replace X input first argument. That's a giant string, and do regular expression. This is how you do regular expression in Wolfram language. You see, this part represents a regular expression, and here is a regular expression you are probably familiar with if you code Python, C, Java, not C, Python, JavaScript, and so on, Ruby. And you want to replace it by empty string. So that will remove all the tags, HTML tags, okay? And now you can just simply call word count, okay? So let's paste it here so you can see word count input. There it is. So you see, so V happens 376 times, N happens 319 times, okay? So that's the word count. Now let's say, okay, this is kind of long. We want to truncate it. So now, this data, you can see this thing, the output, that is in Wolfram language, it's called association. Okay, so let me go to it. So that's called association list. It's just called association in Wolfram language. And that basically means a key value pair. In other languages, it's called hash table or map, or in Python, it's called dictionary, okay? Basically the same thing, key value pairs in an efficient way. That's a key point, because otherwise you can just have list of pairs or array of pairs, but that's not efficient. So hash table, the association list. Now, okay, so now we got the association, this is the output, so it's in this data structure. Now, word count, now you can give it 2. That means count every 2 word phrases, okay? So let's evaluate it. Let's see what we get. You see, one of the nice things about Wolfram language is everything is so, all the functions are built in, because otherwise in Python, for example, if you want to do, there's no such function for word count. You have to do a hash table. You have to parse the file, read every word, split the big giant string by a space, then remove the comma and so on. Then you loop through every word, then you add them to a hash table as a key. And if the key already exists, you increment the value by 1. That's how you do word count in Python and basically essentially every other language. But in Wolfram language, there's so many things built in. Now, in this case, we are doing a word count, but bigram phrases. Okay, let me show you maybe I should show you. Okay, so I can, in XA Wolfram mod, you can search online, I talked about. So in XA Wolfram mod in Emacs, I can just press a key. Wait, not that key. I can, I want to know what's the documentation for word count function. So press a key. We get into the Wolfram language reference. Turn on JavaScript. Okay, so here's the word count, right? So but you can give a second argument n that will give you the n-gram. So if n is 2, that will give you the count of n-gram. Okay, so show more. When the output is huge, like 10,000 lines, 10,000, then Wolfram language automatically truncate the output, then allows you to, show all or show more or show less. So let's show more. Okay, so now we got a lot. So you can see the king, the two-word phrase, the king, happened 13 times. The visor, the vase happens 11 times. The fish happened 12 times. Okay, so that is the now, are they sorted by frequency? Yes, they are. So this A something happened 234 times. Now, this is probably an error. This is a encoding error, okay? Encoding, I haven't figured out. Let me show you what does that mean? What's an encoding error? So you can see, so let me let me magnify. So you can see what I have here is a this character, okay, that's a curly quote. So curly quote, it's called left double quotation mark, it's curly quote. And this happens, for example, let's search for it. You see, for every time there's a quote, I use a curly quote. For example, this is, and show in browser. If we show this in browser, you can also see, if you search for curly quote, let's copy that. So search for it. You see, there it is. It's hard to see because you see there. Oh, it's interesting. You see, in the browser, in the Firefox, when you search the beginning curly quote, it will also find the end curly quote. Oh yeah, that's because the Unicode equivalence, that's interesting. So let's search again. So anyway, the point is, you have this curly quote, and those are not ASCII characters, okay? So you can see lots of occurrences. So it has to do with encoding, and here, this is not correct, there's no character A hat, okay? There's no such character in this file. But however, that's because encoding error. I haven't figured that out, why that happens, so. But that hat A is probably came from the curly quote, encoding error, the curly quote there. Okay, so that's about encoding. So let's ignore it, let's ignore those. So let's see, of the happens 33 times. Let's search for of the. There it is. Okay, so now and they are sorted, okay? Now we want to, let's say, how do you truncate a hash table? In other languages, I'm not sure you do have a function. Wolfram language's hash table is so rich. So let me show you, okay? So, okay, close that. Now let's go to talk show again. Let's open that new window. It's too big. Let's go to talk show. Today's talk show. This one, show in browser. Go back. Yeah, show in browser. What we want to do is so I want to show you the Wolfram association list. So I've been working on this in the past few days. So all these are about association list. So this is how you get values, and this is how you add key, and so on. And right now we want to truncate. Yeah. In most languages, you have get value, check key existence. Let me show you, okay? So let's go to Python. And let's go to emac_lisp, okay? So for example, in emac_lisp, you also have association list. Because Wolfram language you can consider it as a family of Lisp. Very interesting. So, in Lisp, you also have the association list. they almost work exactly, very similar to Wolfram language. You can see, very similar. But in Lisp, you also have hash table, which is dedicated its actual hash table, while the Lisp association list is not really a hash table. It's just a list of pairs. So anyway, so in most other languages, you have, how do you get a value by a key, get value by a key. Then you have get pairs by key, check a key exists, get pair by value, add an element, add a key value pair. That's about it in most other languages. Similarly in Python. So let's show Python. So in Python, it's called dictionary. So you can, create a dictionary, add entry, delete the entry, check key exists, get keys value, get count, get all keys, get all values. And how do you loop them? What type can be used in key in dictionary? And then you have how do you loop through a dictionary? Then you have dictionary methods. So that's all the dictionary methods. Basically, in every language, that's about it. Okay, but in Wolfram language, is far more rich. You can. So let's go back to Wolfram language. Yeah. So you can add a key, delete a key. You can let me show you something interesting. Okay, so this is add a key, delete by key. Let's see, get value. You see, let me show you about the get value function. So in Python, you want to get a value, you just dictionary.get. Okay, return the value of a key if it exists. Okay, that's basically it. Now, in Wolfram language, you can, you use the lookup function. But what you can do is that you can specify more than one key in one shot. You see, that's a kind of the extra power of Wolfram language. And then you can also specify more than one hash table in one shot. So all this bunch of, suppose you have thousands of hash tables. You want to know all of them, get the key, value of a key. So you can do it one shot. You don't have to do a loop. Typically in other languages, then you have to do a loop through a bunch of hash tables, or dictionary. So that's one of the power. Okay, one of the power. Now I want, and there's a lot more. So a lot more. So so for example, this miscellaneous, I haven't read a tutorial of them yet, but I'll get to them. You can also do union on a key, union and intersection on a key. Do I have them here somewhere? Union and intersection on a key. You can do a filter. You can filter a dictionary by key, here, okay? You can filter a dictionary by a function on the key. But you can also filter by a pattern, okay? So lots of rich things. So let me get on, okay? So hello, T-Corfs. Thank you. So T-Corf says, thank you for the large repository of knowledge on your website. Much better than dead internet AI spam that exists now, where, yeah, exactly. Yeah, in the past 10 days, Google, Facebook, Twitter, they poisoned the internet. So these days, and then the Malaysian and Zoomer, these days, if you search anything, you won't find actual information. Doesn't matter, it's programming. Basically, the only thing you get is Stack Overflow. So you type something, especially on programming stuff, you'll find technical blogs by nerds that's very rich information. But today, every page is saying the same thing, copy and paste, especially from spam tutorial website, tutorial point, they copy, there's no content. And part of the problem is because Google, algorithmic control, they, lots of money is the ultimate reason. So anyway, thank you for the donation, and could you explain what is a hash table, please? Okay, hash table is just a key value pair. Okay, so hash table, well, if you know Python, in Python it's called dictionary. It's just key value pairs. The purpose of that is allows you to accumulate a bunch of key, and for example, you have persons' names. You want to know their age. So it's kind of like a database in some sense. So you can have lots of names, John, Mary. Each name should be unique. Suppose they are social security ID. So a unique name, then each one has a value. So you can quickly, the point is fast. Okay, that's the point. The point is that you can quickly query this data structure by a key and get their value, such as a person's age, and so on. Now, this is in contrast to a list. You can do the same thing by a list or array, whatever your programming language is called. Basically you have a giant list of pairs, where a nested list, each element is again a list of two things, name and value, or key and value. You can do that with a list, but the problem is array or list. Every time you want to check if some key exists, you have to literally loop through every item. Okay, that's what happens with the array data structure or list, technically called linked list, depending on which language, so that is the point of hash table or dictionary, or sometimes it's called map. In Java and JavaScript, it's called map. Okay, so let me show you some Golang JavaScript. Okay, so in JavaScript, for example, that thing is called a map object, and it's added there. Okay, so in 2015, JavaScript added several new objects. One of them is map. Now, what is map? Map is basically key value pairs. Now, if you don't know JavaScript, you might ask, if you already know, what's the difference between object? Object is already a collection of key value pairs. Well, the problem with object is that it's a hack. Map object, the new one added in 2015, is the actual real hash table. For example, you can get the length, how many items in them. So anyway, that's JavaScript. So you can, create a new map. It's called map. It's essentially dictionary or hash table. They are all the same thing. Okay, just different languages have different names for them. So you can add a new item. You can, you can delete a item by key and a pair by key. You can check if a key exists. You can, and so on. So that's JavaScript. It calls them map. In Java, it's also called map. Okay, but in Python, it's called dictionary. Okay, in Golang, it's called hash table, I think. In Golang, let's see, array/map. Okay, in Golang, it's also called map. So you can see, create. You can see get value. That's how you get value in Golang, by a key. You can set value, so on. Okay, that's what hash table is. Let's see. Let's go back. Okay, so I want to actually truncate this. I want to truncate this association list. Let's go back. I'm gonna read the comment in a minute. Okay, so how do you truncate? Let's see. Take. Okay. Okay, I think take is what we want. take is a function in Wolfram language that gives you the first n elements, okay? And I believe it works on list, and it also works on association. Yeah, exactly. Yeah. Okay, so let's try take. So we have this word count. Okay, so let's, this is very long. So let me show you. Okay, so let's do this again. Word count. So you got a huge list, and now you want to get the length. Okay, so now let's use length. This is a postfix notation. So you have 4,700 of them. Okay, now you do take. Okay, so you let me take the first 100, one of them. Okay, do it. There it is. That's the first 100. Let's take first 50. Let's say take the first 20. Okay, there it is. That's the output. Now let's see how many items are there. Let's verify. Okay, 20. So take is how you truncate a association. Okay, so we got this. Okay, let me get on to what we want to do today. So I want to not just do the count of one single file. I want to go through a list of directories and count all. I have 7,000 files in my let me show you. So I have something like xali info. So let's go to PowerShell, and what's going on? Recurse file filter. Okay, filter by, I want all HTML files, and that's gonna be a long list. Okay, so stop. Let's do it again. Now pipe it to measure. So I want to know how many. So I have 7,700 HTML files on xali info, not counting xali.org. So all these, so I want to do word count on all these, files. That's what we are doing. So we want to read the directory. Okay, so let's see, how do we read a directory? So Wolfram language, true false equality. So we have read file, list files. There it is. File names, string pattern, directory. There it is. That's the thing we want. Okay, copy it. So let's do it here. Now string pattern will be, let's just say star HTML. You can also use a regular expression. Now directory will be, let's say directory is, for now, let's limit it to XR Talk Show. Okay, so here is the directory, XR Talk Show. So there are 700 files in XR Talk Show. Okay, copy that directory, and so that's the directory, and this is the depth. Okay, it's depth. Since in XR Talk Show there's essentially no subder, so I mean this doesn't matter. Let's say 10. Okay, evaluate it. Okay, so it gives you. It returns. It returns a list of files. Okay, it's quite long, so 700 files. Yeah. So now we can do, if you say length, 400. Oh, what? 444. Wait, shouldn't it be 700? What's going on? Oh yeah, because I have a lot of text files. Yeah, but here we are not counting text files. Okay, yeah. So 440 HTML files. Now we want to go through the directory, okay? So let's see what we want to do. Navigate directory. We want to, we can do a map. We want to map a function to all these. Actually, I have already written here somewhere. So here is a script to find and replace all files in a directory. So process file, write string, scan. Yeah, so we can use scan. So let's look at the scan function. Okay. Scan evaluate function applied to each element of expression in turn. Okay, that's what we want. We can also use map, but scan is just like map, except that it does not return a value. Okay, let's use scan. So actually it's much faster if I work in Emacs. So let's do that in Emacs. Scan. So scan, yeah, we want to show a list of directories. So here is, let me just make this clear. The equals to X files, so that's a bunch of files. And now we want to write a function. Okay, function equals to, we can do it this way. There are many ways to do it, but I'm just going to do it in the kind of the simple way. So function, one argument X, and the body of the function will be, yeah, you need to read the file. So read string, there it is. So function X is the argument, the parameter, and we want to read, yeah, X is a file name. So X, so we want to read a string, then feed it to word count, and yeah, and we don't want to take, we don't want to truncate it. Okay, so here is a function. So the function is given X is a file path, and we read it and do word count, and let's say word count 1, just for simplicity for now. Okay, so now we got a function. Now we want to scan. Now remember the scan, the syntax is a function expression level spec. Okay, so the function is f, the expression is X files, and level spec is the depth of the expression. In this case we just want 1, so by default it will work. Let's see, apply to each element. Yeah. So okay, so we got these 3 things. Let's try this. Okay. But now So each function, it will return a hash table. Okay. Yeah, we can run this, but the result won't be correct. So let's try it. It's gonna read each file, and each time its a result is a hash table, but it doesn't return anything because you used scan. So instead, you want to use map instead. Okay, so then that will return 400 hash table. Okay, so you can see, and you can see percentage sign stands for last output. So now we use a postfix operator and apply the function length to it to see how many items. So we got 444 hash table. Okay, now we want to merge all of them, all of the hash table. Each one we want to, if one hash table has the word XA happen 4 times, another hash table have XA happen 3 times, we want to combine them. Okay, so we basically merge hash table. So how you do that? Let's see. So we go back to Wolfram language. Wolfram language association. Okay, let's look at them. Association key value pairs. Merge. Okay, there's a function merge. Now, there are probably new, more efficient ways, but I don't know yet. Association, the association data structure is actually new in Wolfram language around 2016 or so. It's pretty new, so it's very interesting because Wolfram language began in 1989, and the hash table data structure is not there for 25 years. Only in 2016. So let's see how when is it added. You see, 2014. So after 25 years, then Wolfram language added the hash table data structure. I can tell you why, because there's a design issue. The association data structure is actually kind of against the term rewriting model of Wolfram language. That's why it's added so late. So why do they wait until 25 years to add this? Because in all other languages, starting with Perl in 1995, hash table becomes critical. In C, before that, you don't have, it's not in almost every language. Because if you want a hash table, do it yourself, just write it yourself. But as over the decades, as a machine gets faster, more higher level languages, such as starting with Perl, then Python and Ruby, every language has a hash table data structure built in, so that becomes very popular. So all the programmers, when they go to Wolfram language, they are going like, what? You don't have hash table? Like, what's the deal? I think that's the major reason Wolfram language added association list. But actually, I'm not sure it should, because that's another topic. That's about the design of a language. I think it should be automatically done behind the scenes when you have a list of pairs. Okay, but anyway, that's another topic. That's about design of the language and the uniform syntax, like one single syntax represent everything. Because when you think about hash table, a list of key value pairs, and when you think about a list of pairs, they are actually the same thing, at least from an interface point of view. From a syntax point of view and combined with interface point of view, they are actually the same thing. The only difference is that hash table performs much faster. Now, that's an implementation issue. Therefore, as a programming language, you should not your compiler should be smart, so that when you see a list of 10,000 pairs, it should automatically compile them to a hash table behind the scenes. That's the power. So I think that Wolfram language should do that, but for some reason they didn't. Of course, there are other complexities and considerations, but in general, I think that should be done. But anyway, so Wolfram language now has an association, so it's kind of new in 2014, and I haven't, by 2014, I don't have Wolfram language, so I'm not very familiar with association. So right now we want to merge to association. Okay, let's see how to do that. So merge. Okay, here is the documentation for merge. So you just give a list of associations and you add a function. Okay, easy enough. So let's do it. So here is a map. So let's see, let's define this to be, so we got a bunch of hash tables. Okay, now we want to map through the hash table, right? Yeah, we want to merge them into a single one. Okay, merge is the function. The first argument is a list of associations. The second argument is a function. So let's write it on the spot, lambda. Now in Lisp, this function, it would be called lambda. In JavaScript, it's called function. In Python, it's called also lambda, but Python is has a crippled lambda. So anyway, so function. So this function, what this function will do is it will tell Wolfram language how do you merge two entries of the same key. Okay, so what does the function take? Let's read about it. Merge the association using the function f to combine values when with the same key. Okay, so the function is fed two arguments, I suppose. Let's see. Okay, so the function only take one argument. I mean, two arguments, and each argument is a value. So this merge function, it will find all the keys that's the same, and will merge them. So each key has a value. So this function will take different values from different association list, and this function will tell it. This function will actually take two or more arguments depending on how many associations you have. In our case, we have 440 associations. So this function, each time will be fed 440 values of the key. But what would it do? So it should, so this function is going to take arbitrary number of arguments, two or more, and it should return one single argument, one single value, and in our case, we just want to add them together. So we don't even need to define our function. The function we need already exists. It's called total. Okay, total is just like in other languages. In Haskell, it's sum. Okay, that's what we want. Okay, so that's it. So let's see. Copy that back to Wolfram language. And let's see. Yeah, so that should do it. That should be the final result. Okay, fantastic. So we got 12,000 keys. We got about 12,000 keys in all the associations. And that's just so let's now take the let's give it a value. So let's say word count equals to, so we assign them to a variable, so we don't have to compute it again and again. So let's do it this way, okay? So that's it. So now let's just compute it one more time. Do it. So how am I doing? 4 people. Oh, Jesus. 3 people watching. Okay, so here's a result. Let's see word count. And let's say how many items there. 12,972. Okay. And let's say, let's show the top 10 result. Okay. So take the top 20. Okay, so in XR Talk Show directory, the word Kobo happens 5 times. XR happens 2,200 times. Okay, and you can see we have a bunch of HTML tags there. Now we forgot to remove them, so we need to modify this. Yeah, we forgot to remove them. Yeah, so let's copy the remove read stream. So here's the read stream, and then you want to, yeah, do string replace. There it is. Okay, let's do it again. So now you should get rid of the HTML tags. Okay, there it is. Now copy that, paste it. There it is, much better. So for some reason Kobo happened 5 times. Now why is it not sorted? Okay, it's not sorted. Now we need to sort it. Let's see, how do you sort? We want to sort a hash table by their value. Okay, now in other languages you basically have to, there's no built-in function, you have to convert them to a list, then sort it. that's what you have to do in Python, in Golang, in all the other languages. But let's see how we do it in Wolfram language. So yeah, so let's go to association. And miscellaneous, I still need to work on this. Key sort. Do we have a value sort? Key, let's see, key sort. Key sort by keys. Oh yeah, so all you have to do is just say sort. Now many functions, you know, in Wolfram language, you have like tons of functions that works on a list. Okay, all these functions will also work on association list, and when they are applied to association list, they will automatically work on the values. Okay, so that's why you have an extra function for key sort. That's when you want to sort by the key, but otherwise just use sort. Okay, so let's do it again. So let's sort, okay. Sort word count. You can see, okay, now we want to sort in a reverse way because now it sorts 1, 2, 3, 4. Okay, we want to reverse. So how do you reverse? There's an option to say in reverse order. You have sort by reverse sort. Okay, there's actually a dedicated function to reverse the order. Reverse sort. Okay, so let's say reverse sort. Okay, evaluate it. There it is. So XA happened 2,000 something times. Show happens 1,600 times. Talk happens 1,600 times. That's correct. That's all the things in XA talk show. Okay. So now we getting there. So the goal is to do all the 7,000 files on my website. And let's see what's the word that's used most frequently. Okay, so let's add the reverse sort. So hash table. So let's see all the merge of all the hash table. Okay, then we want to sort it. Yeah, reverse sort. We want to sort it. Then we want to yeah, okay, that's it. That's that. Yeah, we can now, it's all clear. This is our whole code. Do it. Yeah, so now we are going to do it to the entire directory now of XAD info. First of all, let's change it to, let's say, Python directory. Okay, you know, the entire, let me show you. Go to Python, so you can see here's my Python. There's only 140 files. Let's go to Emacs. Emacs directory, there are 800 files. Okay, so let's do my Emacs directory. Let's see what's the most frequently used word. Okay, it's already done. So there is the result. Wow, this is 800 files. So Emacs, the word Emacs happens 44 times. Okay, now let's do the entire XAD info directory of 7,000 files. Do it. Fantastic! Here's the result. Fantastic. So last result, let's do a take. Let's, you know, show the first 50, top 50. So I'm gonna write a function cryptic here. Let's say top 100. So here is the final result. This is the top 100 words happened in xad.info, about 7,000 files. So Emacs happens the most, then XAD, then JavaScript, then end. Oh my God, the word JavaScript happened more often than the conjunction end. Wait, I'm not sure this is correct. Wait, no, I think this is not correct. This is incorrect. Because the word the should happen more often. Okay, we got the error somewhere. Read files, xad info. Okay, I know what to do. You know, I think sometimes there's a cache issue in Wolfram language. Like once you read a file, somehow it stays in a cache. Anyway, the result here is incorrect. I don't think so. So let's close that. Let's try to do this again fresh. Okay. So what I'm going to do is quit Wolfram language, don't save, and start over. And that'll be it for today. So close that. Okay, so actually close that. Okay, so start anew. Evaluate it. Okay, magnify. Okay, and let's do this. Let's make sure it's correct. Function x read string regular expression and count word count returns a association. okay? Then you want to apply that function to all files. That's correct. Then you want to merge the hash table by total, okay? Then reverse sort. Then yeah, so you do take the first argument is that, then you take the first 100 items, okay? So that is the code. Paste it here, do it. This is kind of strange. There is the word. Now the word happens even less than Emacs. Is that true? Oh yeah, because every file you have the H1 header, then you have the title, they are all Emacs. Actually, so this is correct. Very interesting. And XAR happens the most often because every page you have a, you have the footer. Yeah, that makes sense. In JavaScript, because in JavaScript directory, you have like 700, you have 900 files, and almost every one of them have several words. Oh yeah, because all the panels, you see, that's why, yeah. You see all the panels, wait, yeah, well, because, well, it does make sense because there's lots of files here, JavaScript. Okay, that's the result. So let me read the comments. We shut down in 1 minute. So there's a question from Crazy Frog. Is it worth paying for Wolfram rather than using this for everything? Yeah, well, Wolfram language is a magnitude beyond Lisp. I talked about that many times. So, but the thing is, you have a free version of Wolfram engine you can start with. Just go to my website. You can see download free Wolfram engine. Watch my video. I talked about this before. Yes, Julia is a very good language. Julia is a great language. I don't know it though, but from my experience and hear what people say, I think Julia is a great language. But it's not a Wolfram alternative, okay? Depending on what you want to do. If you want to solve equations, symbolic computation, machine learning, AI, Wolfram language is 100 times, 100 times in whatever, 100 times a magnitude more powerful, more rich than all the whatever Julia, Haskell, Clojure, whatever fancy language. That's just that's just true. Okay, bye guys. Thank you guys for watching. Donate, okay? Pay me. Bye. So I'm gonna shut down. And I'm going to yeah, so I'm shutting down, clean up my files. So here is what, yeah, this is today's talk show. I'm gonna clean up. So that's all you need. So here is a code. Let me show you. So here is a code for going through 7,000 files and get their word count. You can, if you add this word count, if you say, where's word count? Here, okay. So if you say 2, then you get a list of all bigrams. Okay, let's run it. Okay, just for the sake of interesting. What's the most frequent occurrences of two-word sequence? Okay, of orgsali.info website. Okay, so Xa talk happens 429 times. Xa then talk show happened 426 times. Yeah, that makes sense. Blog archive, their properties happened 258 times. Emac list 100 happens 230 times. You know, that's so this is a two-word phrase. Programming blog happens 78 times. Yeah, that's interesting. Now let's change it to 3. Now, because if you change this to 2 or 3, then in other languages it's a lot more code. You know, because then you have to partition, you know, given a list of words, before you simply do a split, you know, then you loop through each words, then you tally them, put them into a hash table by key. But now if you want a phrase of 2 word sequences, you can just split them. You have to split them, but you have to kind of a shift split. You know, so in other languages it gets more work. So anyway, let's do 3. Let's see what's the 3-word combination. So Xa talk show happens 400 times. Curves and their properties 258 times. And their properties, there it is. Xa Emacs blog. Okay, that's interesting, and somewhat it's surprising, because I thought it would be and that, you know, they are, there is, something like that, but it turns out it's all my word titles, like file titles and so on. Emac list coding, their properties, roulette, their properties spiral, so that's only 11 times. Yeah, very interesting. What about, you know, I wonder if you go through an English text, then we can do it. So let's see, let's try Alice in Wonderland. Okay, let's try Alice in Wonderland. Okay, Wordy blog, let me show you. So Wordy English, literature classics. Then you have Alice in Wonderland. Let's see. Let's get the word tally. Let's copy the directory file path. There it is. There it is. Then there it is. Put it here. Okay. Let's do Alice in Wonderland. Okay. And actually word count. Yeah. So let's do it here. You know, if there's a flaw in Wolfram language, I would say speed, okay, because the speed is not so great. You know, for any task, if you write in Golang, in Python, let's say it takes you 1 hour, okay, especially if you write it in Golang, in JavaScript, it might take you 2 hours, but it's fast. You know, you take 2 hours to write it, and the result come out, let's say 5 seconds. But in Wolfram, it takes you 1 minute to code it, save you 60 times the human effort. But the result is slower, you know, slower than Golang or Python. Depends. For example, it really depends. If you have a very specialized task, then Wolfram is 100 times faster than whatever language you use. For example, let's list pi to 2,000 places, okay? Doesn't matter what language you do, you try to do this. It's gonna be 100 times slower than Wolfram language, okay? And in Wolfram language, you can code this in 1 minute, you know, in 1 second. Pi to the 2,000 places, you can say 5,000, 10,000, you know, it depends on your memory and so on. So anyway, so Alice in Wonderland, and if we count words, it's going to be, wait, that's 2, okay, that's two-word phrases. Let's just say one. So the and a to, that's expected, space of, that's a quotation sign, Alice, it, she. Okay, that makes sense. But let's see. Yeah, so out, they, one, this, not, if. Okay, now let's see two-word phrases. Hey, Ripper, thank you, Ripper. Ripper says, to what extent do you think Lisp expression, symbolic expression's power for most programmers is essentially serving as an association dictionary and not because of macros? To what extent do you think Lisp's symbolic expression power for most programmers is essentially serving as an association dictionary? No, I don't think, I don't think that's true. So I think you are saying that what do you mean serving as an association dictionary? So let me just explain what maybe that's your question. So Lisp, a lot of Lisp fanatics, they love Lisp because for several reasons. They like the Lisp syntax because everything is parentheses, and everything, everything is just a function call. So functional programming is part of it. The nested, fairly regular syntax, and you deal with symbols, so that allows you to have macros, which is kind of like term rewriting, but basic one. I did explanation of this in lots of my previous videos, so you might check out that. So for example, if you go to Wolfram language, you go to the, okay, let me read it. Okay, so let me say first that I did a lot about Lisp language. I did a lot of video about Lisp language. Where is it? No problem. Let's see. Command serving. Yeah. So search for that. You'll find several videos talking about the Lisp syntax and different languages. Why Lisp love them. So that's very much related. So let me see. Okay, so you are saying, yeah, so I think I know what you're saying. So you are saying, Lisp programmers, they love Lisp. Let me show you some Lisp code. Okay, so here's a Lisp code. And let's go to, so for example, these are Lisp code. And let's go to some, lots of, parentheses. And, so this, Lisp people, they love them, Lisp. For one of the big reasons is that so-called homoiconicity, okay, meaning that the syntax corresponds to the data, something like that. That I don't think that makes sense. So basically, what they are saying is that let me show you. Okay, so that's so that's a different topic. So, okay, so you might want to read these fundamental problems of Lisp, okay, and so let's see, fundamental problems of Lisp, syntax irregularities, syntax semantic correspondence. Okay, that's what I think that's what you are talking about. Homoiconicity, okay, and source code transformation, okay, yeah, homoiconicity, So a lot of these people, they think of the syntax as data. Data is a language. Language is data, something like that. I don't think that makes sense at all. In fact, what they actually appreciate, the gist of their appreciation is not about some data and language are the same thing. That's incorrect. The gist of their appreciation is regularity of the syntax. Okay, not some homoiconicity crap. Okay, these people, one of the major reasons these people love Lisp languages is because the regularity of syntax. Okay, that's my view. Okay, that's my view for fighting with the Lisp phonetics for 20 years. Okay, regularity of syntax. For example, other example are XML and Wolfram language. Okay, you have regularity of syntax. Okay, I talked about this many times in my video. Now, okay, so that's what these people say about SEXP, symbolic expression. So you are saying, symbolic expression are useful for storing data, and this programming use them in a productive way, like Perl and PHP or JavaScript programmers use associative array. I think I know what you are saying. So anyway, so these people like that, okay? But they don't have anything to do with associative arrays, though. In Lisp you do have associative list and hash table, but that's a different thing. And these people do not actually use them much. These programmers, they love to use just list, okay? And associative list is a list, but hash table in Lisp is not a list. Okay, so for example, if you're looking at the Emacs Lisp, you have association list, which is a list, but it has a problem of inefficiency when you have more than 10 items. If you have more than, let's say, 10 items of pairs, key value pairs, then you want to use an actual hash table, which ceases to be a list. Because, look at the hash table syntax, it stopped having this typical symbolic expression form. You see, look at this. Here is a hash table, a literal expression for hash table for Emacs Lisp. You can see it's not a list anymore. It's kind of got this special syntax. And these programmers in Emacs Lisp, for example, you don't see this used much. People go back to use association list, which you can see here, the syntax is actually is a list. Okay, so I think that's what you kind of saying. So what I'm saying is that so I guess a lot of people, these people like the, what I'm saying is that they will say they like the idea of homoiconicity, or data is program is data. Now, I think that doesn't make much sense. What they actually love, the gist, the essence is regularity of syntax, okay? Okay, that's it for today. Bye. It's too long. Bye, guys.